Hey guys, today we are going to be talking about chemical kinetics, aka what kind of factors can increase the rate of a chemical reaction. So, without further ado, let's jump into it. I'm going to make two videos today. One just talking about the factors, and then I'm going to create a separate video talking about energy diagrams because they can be a little bit trickier. So, just be aware there are two videos for today's lesson. All right, so first let's talk about kinetics. So throwback to the beginning of the semester when we talked about potential versus kinetic energy. Remember, kinetic energy is the energy of movement. So we're talking about these molecules in motion. So kinetics is going to deal with rates of reactions or how quickly a reaction occurs. Your job today is to be able to tell me if these certain factors will increase or decrease the rate of a reaction. So the collision theory is just the frequency of collisions means that more collisions will equal a faster rate of reaction. So basically, if more of these molecules are bumping into each other, it's going to have more opportunity for bonds to form and for our products to be made in our chemical reaction. So more collisions equals a faster rate. Now, these collisions also need to be effective, so they must have proper orientation and enough energy to meet and then form that bond. This is basically the first video that you guys watch. If you remember back in your first lesson, when you watched the TED Talk video of the chemical equilibrium with the people walking around and bumping into each other and like switching limbs, that was also collision theory. So this is just the same thing, saying that these molecules have to be in the correct orientation. They have to have enough energy to bump into each other, and the force of that collision has to be so that the products can be formed. So now let's talk about the factors that we have to know that affects the rate of reactions. The first factor is going to be the type of substance. So ionic substances react faster because the bonds require less energy to break. And then our covalent bonds will react more slowly. So the bonds require more energy to break. And this is just a reminder of a covalent equation right here. So at this point in time, in this course, you guys should be able to look at a molecule and determine, is it ionic or is it covalent, right? Because at this point we know ionic bonds occur between a metal and a nonmetal, and covalent bonds occur between two nonmetals. So in an application situation, you could be given two compounds, two reactions, and be able to say, okay, this one will have a faster reaction because it's ionic, or this one will have a slower reaction because it's covalent. Okay, so that's the application there. Another factor that can affect rate is temperature. So as we increase temperature, we increase the kinetic energy of the system. So as temperature increases, the molecules are going to move faster. So their kinetic energy is going to increase. Now, let's think about the timeline of events for this. So if we increase our energy, the molecules are going to move faster. If they're moving faster, they have that energy needed to now collide with the other molecules and make the new products. But if they're moving fast, that also gives them the opportunity to reach those other molecules and collide with those other molecules more quickly. So if we increase our temperature, we are also going to increase the rate of reaction. Third thing would be concentration increases. So if you increase your concentration of your molecules, there's going to be more collisions, right? Because if you have more molecules in a given amount of space, chances are the likelihood of those molecules coming into contact with each other is going to increase, which will increase the rate of reaction, right? So this is just the rate at which the products are formed, okay? Or if we're going in the reverse direction, the rate at which they're broken apart. But when we're talking about products being formed, if you have a larger concentration in a small area, then you're going to have those molecules be more likely to come into contact with each other, again, doing this quickly, so you're increasing the rate of reaction. And with concentration increases, you can do this a couple ways. So remember, concentration is just like the molecules per volume area. So you can do this by either adding more of your reactant, or you can get a smaller flask or whatever it is you're doing your experiment in. If you have a smaller container, that would also increase concentration because you would have more particles in a smaller area. The fourth thing is surface area, very similar to concentration. It increases the rate due to increased reactant interactions or collisions. So you're just increasing the likelihood that these molecules are going to come into contact with each other and therefore increase the rate of reaction, right? If you're increasing the likelihood of them coming together, that means that this reaction, these products are being formed quicker, and then your overall rate of reaction is higher. Pressure increases. Now this one is unique, and this is actually in your exit ticket today. So increasing the rate of reactions involving gases only. What this means is that increasing pressure will increase the rate of reaction, but only in a gaseous system. So when we look at chemical equations, like we learned last week, in some of those equations, you'll have the subscripts that have, like in parentheses, it'll say AQ for aqueous or G for a gas. This only applies to those gaseous reactions. So if the pressure increases in a gaseous system, then you will see an increase in the rate of reaction. And this happens because as the pressure increases, the volume decreases. So the space between the molecules also decreases. So same idea as when you're increasing the concentration. This, of course, increases the frequency of collisions and then leads to a higher rate of reaction. But again, pressure increases only affect gaseous systems. And a catalyst. So this is the last thing we're talking about today, is how does a catalyst affect a chemical reaction? Well, if you have seen this term before, and I hope you have because you're all coming from biology, this is the same catalyst we would talk about in biology where you're adding it to an enzymatic reaction, right? Catalysts and enzymes, if that rings a bell. A catalyst is a substance that will increase the rate of reaction, and it does this by lowering the activation energy, okay? They remain unchanged during the reaction and can be unused. And we have to make sure we know the definition of activation energy. This is the amount of energy required to start a reaction. So how much energy is needed to get the reaction going? So if we add a catalyst to a chemical reaction, it's going to lower that activation energy. We don't need as much energy to kind of get up and running, so to speak. So the reaction can proceed quicker than without a catalyst. Therefore, the catalyst will increase the rate of reaction. Okay, now this is just a quick review of everything we just went over. So remember, ionic solutions have faster reactions. If you increase temperature, you increase the rate of reaction. Increase concentration, increase rate of reaction. More surface area, faster reaction. Increase pressure, increased rate of reaction for gases only. And then catalysts speed up reactions. Okay, so that is literally just the summary of what we just talked about. Now, of course, the answer or the question is, how do we apply this in this class? Like, how does this apply to your test questions, quiz questions? Like, how are you supposed to be able to transfer this to the real world? Well, in instances like this, you'll be given a problem or a situation where you just have to be able to interpret what will happen to the rate of the reaction. So, for example, Tim and Johnny are in the lab, they're performing a chemical reaction, and they decide to increase the temperature of their reactants, right? Increase the temperature of the molecules. What is going to happen to the rate of the reaction? Well, you should know that, okay, I know that an increase in the temperature is going to lead to an overall increase in kinetic energy, thereby allowing more collisions to occur, thereby increasing the rate of reaction. So you would tell me, oh, the rate of the reaction is going to increase, right? You just have to be able to identify these factors that will increase the reaction rate and tell me what will happen. And also for our catalysts, you need to be able to define a catalyst, tell me how it speeds up a reaction, aka by lowering the activation energy. So just make sure we know the definition of a catalyst and activation energy, and that catalyst will speed up reactions by lowering that energy. Okay? So now that you're done with this video, go on to the next one and watch the video on potential energy diagrams, and then you will be done with your note portion for your lesson today.